Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. My theoretical physics mentor, Larson, was also a theoretical economist. In fact, physics and economics usually go together, especially at the high end. So I also work as a theoretical economist. I've made all of Dewey's work in physical science fully computational, and I've also made all of his work in economics fully computational. The result is this paper, Theory of Microeconomics and Macroeconomics, Larsonian Econophysics. This will be part 3 of the paper. I do want to just back up a little bit to go back over part 2. The last sentence got cut off. I'm doing these seminars or lectures 1/2 hour, so it's pretty stringent. I want to repeat that for long-term survival of the firm, the managers must try, for each period, to 1, increase the ratio of K sub R, that's the revenue coefficient, to the number of employees, N sub B. That is, increase relative revenue productivity per employee. 2, decrease K sub C divided by N sub B. That is, reduce the relative cost per employee. And 3, increase the reserves to get through tough times. And I've devoted much of my career to applied optimization for managers. That's my optimal manager software package. Engineers, that's my optimal engineer software package. And optimal control designer. And I also have optimal scientist for scientists. And you can see references 29 through 33 for those. Now, the coefficients K sub R and K sub C are normalized so that the average firm in the particular industry sector, the values are equal to 1. A more successful firm will have a higher value of K sub R and a lower value of K sub C, and vice versa for a less successful firm. Many phenomena, including the distribution of individual IQs, follow the bell curve or Gaussian probability distribution, so we can assume that this distribution applies to the coefficients. The ratio of K sub R to K sub C also represents a single figure of merit or benefit to cost ratio of the firm in the sector, and is itself a probability distribution. Okay, so now we'll really start part 3. Now, of interest here is this question: what is the ratio of K sub R, K sub C, that is the revenue coefficient to the cost coefficient, below which will put the business in jeopardy? If PV, that's present value, goes to 0, the firm goes out of business and all involved become unemployed. For algebraic simplicity, let's consider just one period for equation 2.4 and solve for the ratio of K sub R over K sub C in order for PV to be greater than 0 with no help from reserves so that the firm survives. It's clear from inspection that KR times TR sub T, that's for period T, must be greater than K sub C times TC for period T for positive present values. So therefore, we have the ratio of K sub R sub T to K sub C sub T must be greater than the total cost, or TC sub T divided by TR sub T. Okay? Very important. That's equation 2-8. The ratio of total cost to total revenue of the average firm in the sector then represents the survival limit for all firms in the sector. The lower this ratio, the lower the survival limit for all firms in the sector. Over many periods of time, not just the one period we just considered, a particular firm's figure of merit, that is K sub R divided by K sub C, will fluctuate, but clearly it must usually be above the average TC divided by TR, that's total cost to total revenue. When it's not, the firm's reserves will decrease. When it's way above average, when it's way above the average TC divided by TR, the firm may increase its reserves, which is highly advisable. You know, we're in this current depression due to the pandemic and the shutdown. So, man, if your business didn't have reserves, you'd be out of business in a flash. So I hope that your company has had sufficient reserves to get through this. Okay, continuing. If there is unemployment in a particular sector, the survival limit must be too high in that sector. If there's general unemployment, the general survival limit must be too high. The surplus labor is, quote, substandard, and that its ratio of relative revenue production to relative cost is too low for it to be utilized under current conditions. Of course, for a governmental agency or for a socialist firm, their survival limit is nearly zero. They are subsidized and very little value is produced. The correct general survival limit is that which provides full employment, and not a whit lower, because otherwise less will be produced. So what is it that causes the survival limit of firms to be so high that we have unemployment? It is government taxes and laws, such as minimum wage laws and prevailing wage laws, for example, the Davis-Bacon Act, and overregulation of business that cause unemployment. It is also the union scale, which mandates the same labor rates across industry, regardless of differences in productivity of the various firms in that sector. So thus, unemployment is not the result of, quote, market failure. To have full employment, we must reduce the survival limit of businesses by repealing minimum wage laws and prevailing wage laws, by deregulating business and discontinuing union scale, and by cutting taxes, particularly property taxes, especially in business downturns. At least with the income tax, it depends on the profit of the business, but property taxes are fixed, so they should definitely be cut in business downturns. Okay, now, a work example utilizing equation 2-4 will be considered after we analyze the representative worker consumer, which we will do now. So this is subsection 2, the representative worker consumer. Well, I don't know why this is. Okay, so the economics literature is full of, quote, utility functions for consumers, but in reality, the maximization problem of a worker consumer is not all that dissimilar from that of the producer-retailer. The worker-consumer wishes to save for retirement, or to make a bequest to the children, or to a charitable foundation, etc. In analogy with equation 2-4, we have problem, a representative worker consumer maximize this following function. That's the present value of the worker consumer is equal to sum over time from periods t equals 1 to the time period, total time period W underscore C, of the total revenue minus total cost divided by the interest function, which is 1 plus RWE, raised to the tth power, plus whatever reserves the worker consumer has or can generate. So where T sub underscore T is the time horizon for the worker producer, and R sub W C is the discount rate. So there's the interest discount rate. If per period we let W equals wage, B equal investment income, TR equals government transfer receipts, and C equals consumption, including any taxes, then we have maximize PV, W underscore C, is equal to the sum over time from period T equals 1 to T sub WC of W sub T, that's the wages, plus B sub T, which is the investment income, plus TR sub T, which is transfers from the government, minus C sub T, which is, obviously the cost, divided by 1 plus R sub WC up to the tth power plus whatever reserves the worker consumer can generate. Okay, so worker consumers are not sector bound, unlike business firms, so we do not need the K sub R and K sub C coefficients here. One could use the two-period overlapping generations model with only W sub T and C sub T in the first period and only B sub T and C sub T in the second period. But in a general situation, each worker consumer has both W sub T and B sub T, and it should be possible to deduce the values for the median or mean individual. This will be done later in the macroeconomics section. The values of TR should drop out on that. Okay. The numerator in the expression is equal to the savings, S sub T. So S sub T equals the wages, W sub T, plus investment income, B sub T, plus government transfer, TR sub T, minus the costs, C sub t. If S is constant over the t years, then an alternative equation for 2-9b is present value of the worker consumer is equal to S, that's the savings, times the interest factor, which is 1 plus R sub W E is C, up to the T sub WC minus 1, divided by R sub WC times 1 plus R sub WC, up to the power T sub WC plus reserves. So engineering economics textbooks like Reference 35 have many more of these types of calculations. The future value of this stream of constant savings amounts to FV, which is future value of the worker consumer, is equal to the savings per period times 1 plus R sub WC up to the power T sub WC minus 1 divided by R sub WC. But this needs to be reduced by the expected cumulative inflation over those T sub WC years, and the symbol for that is inflation sub T. So that's the cumulative inflation. So we have to take that expression 212a and divide by the cumulative inflation in order to get the true value. So if the worker consumer is just starting his or her career, the reserves would be negative due to college loans. On the other hand, if the worker consumer is near retirement, the reserves could include assets which could be sold for cash, like one's house or stock holdings. But this has no effect on the general economic situation, and that's principle 4. Now, let's do some example calculations here. Example calculations for the representative producer-retailer and representative worker-consumer. So subsection 1, the representative producer-retailer. So let's consider 3 restaurant chains in the fast food sector: McDonald's, Ruby Tuesdays, and Wendy's. Originally, we were going to use Burger King instead of Ruby Tuesdays, but Burger King is a Canadian company and does not have 10-K reports. So if you're going to do this for your own business sector, be sure you can get the 10-K reports. They are very valuable. Reference 27 has the 10-K reports from 1993 to 2015 for the 3 companies. And with this data, a spreadsheet can be made to perform the calculation so as to determine the average values for TR and TC. That's total revenue and total cost for the 3 restaurants, and all the other parameters. The Excel spreadsheet is included, by the way, but it's separate. So the Excel spreadsheet is imported into the MathCAD worksheet. So this expression here is how we import an Excel spreadsheet into MathCAD. So we can view columns 1 and 2 of the spreadsheet. We have these expressions here. And this just shows you the first 2 columns. The zeros are actually blank values in the actual spreadsheet, so just ignore that. All right. I'm not going to actually show you the spreadsheet here, but it just gets imported into the MathCAD document. So, from these values, one can see that the average of the 3 firms, that is the representative firm, so to speak, we have the ratio of total cost total revenue equals 0.864156. The 3 companies have average values of the time period for K sub R divided by K sub C of 1.018056, 1.039748, and 0.871473, all above 0.864155. But Wendy's, that's the 3rd number there, is close to the danger zone. For some reason, Wendy's has always been close to the danger zone, but it keeps hanging in. The net earnings to total revenue on average for the 3 firms are 0.150795, 0.036492, and 0.002082. The average earnings per employees at the 3 companies are 7812.84, 1044.58, and 158.63. Note that Wendy's had extraordinary earnings for 2000-2001, but these have been taken out of the computations to avoid distortions. Clearly, McDonald's is the most stable of these 3 companies, followed by Ruby Tuesdays. Wendy's is the least stable. Now, in order to extrapolate the data to the next 10 years to get present values, we need to extract the relevant data from the tables and then use MathCAD's predict function. To keep things simple, we'll extrapolate just the net earnings values. The K sub R, K sub C, and N sub C values drop out of equation 2.4 and do not matter for calculating present values of the individual companies. So again, we're just pulling these numbers from the spreadsheet. And then we use MathCAD's predict function, which is based on Berg's method. And you have to see reference 34 description of this method. By the way, that's not too, it's not so simple to code. I've coded it in True Basic, incidentally. It's a lot easier to use MathCAD. Just the predict function does all of it for you. So now this gives us the extrapolations for these three companies. So here's McDonald's, and we're going from periods 1 to 10, and you can see this is pretty stable. It's pretty nice, net earnings. And here's Ruby Tuesdays, this very jumpy. And note that around here, that's when Ruby's was taken private. I don't know, by the time you're watching this, maybe it's back in the public domain, with public shareholders, but it was taken private. So Company 2 looks like it may have somewhat rocky road ahead. And as of 2016, that seems to be the case. That's when I did this. And here's Wendy's. So you can see Wendy's went negative here. It's bouncing around between negative and positive. So it may or may not survive. I don't know. It seems to be a survivor, but it's always close. Okay, so now we can calculate the present value of these three firms. Our piece of our, we'll set the discount factor to 6.5% or 0.065, which seems kind of reasonable, and we'll keep it constant for each of the 10 years. We're going over a period of 10 years. Now we get the reserves, retained earnings as of the end of 2015. So you can see, I mean, look at the reserves. I'm not going to read this, but the reserves of McDonald's is way better than Ruby Tuesdays, and actually Wendy's has an accumulated deficit. So then we can calculate the present value of McDonald's is 7.878905 times 10 to the 10th power, so 78 billion. Present value of Ruby Tuesdays is, let's see, 831 million. 0.2051, and Wendy's, well, it goes negative. So it doesn't look so good for Wendy's. Management must take action now to ensure the survival of the company. So it's just the way it is. All right, so that's that example. Now let's do an example calculation for the representative worker consumer. So let's consider a recent college graduate, age 22, expecting to work for 43 years and to save $20,000 per year every year, which might be kind of tough to do through thick and thin. But let's hope that they can do that. So the projected present value of this individual is then, again, we'll assume 6.5% as the discount rate. He starts off with a negative reserve of minus 75,000 because of the college debt. So the total number of periods is 43. S is the annual savings, 20,000. And so using the present value equation, we get 2.12 times 10 to the 5th power. So that's, I mean, it's not even $1 million. So we have this alternative equation for present value, and again, it would be 0.2121767 times 10 to the 6. The future value of the assumed savings for the worker consumer at age 65 is then equal to the annual savings times this factor here, 1 plus R sub W C up to the T W over C, W underscore C minus 1 over R sub W C. And that does come out to $4.307075 million, which would be damn good. But unfortunately, we have inflation. So in the 43-year period from 1972 to 2015, there was a cumulative inflation of 467%, according to reference 37. Therefore, if that holds for the next 43 years, which hopefully it won't, but it looks like given what the Fed has been doing, it certainly probably will, the actual value of FE in current dollars would be, and by the way, we have to add 1 to the 4.67, so that gives us 7.596252, or about $0.75 of $1 million worth of today's purchasing power. According to reference 36, the median retirement savings for those between 65 and 74 as of writing this paper amount to a mere $148,900, hardly enough. They should have been more rational in optimizing when younger. So Americans are woefully unprepared for retirement. Okay, wow. You know, this actually would be a good place to stop. This one is only 20 minutes. We could go to 30 minutes, but I'd rather start macroeconomics next time. So I'm going to stop here. This paper, by the way, is free. You can download it from the web. The address, I can put the link in the description. And of course, an implementation of this paper is given in my Optimal Economist software package, an implementation of Larsonian Econophysics. Optimal Economist. You can get it from Transpower Corporation. That would be transpowercorp.com. You can use PayPal. And it's, of course, available from Amazon as well. All right, so please study this paper, and you know, this really is the true economic theory. Completely supersedes everything else that's out there. Thanks for your attention.